We've talked about implicit differentiation, and now I want to show you a couple examples of it. So this first example is x squared plus y squared equals 25. This is in implicit form because we don't have y equals something with just x's. We've got x squared plus y squared equals 25. So the first step that we want to do is use our derivative rules to take the derivative of both sides. So d by dx of x squared plus y squared equals d by dx of 25. So again, just taking the derivative of both sides. Let's start with the right side because it's a little bit easier to know what's going to happen. The derivative of a constant is 0, nice and easy. The derivative of the left side we can also write like this, d by dx of x squared plus d by dx of y squared. And that's just because we know that the sum and difference rules lets us split up a derivative into two pieces. That leaves us with this first derivative that should be, at this point, pretty familiar and easy to calculate. It's just going to be 2x. Now we've got something weird here on the left. And it's a little confusing maybe if you have this y. If you prefer, we can, for a minute here, think about it like this. Y equals f of x. And then we have something like this. D by dx of f of x squared. And this, you can see, is just the chain rule. We've got a square and then a function inside of it. So we'll have 2x plus 2 f of x, which again was just y, and then d by dx of y. And that equals 0, just like the whole right side had been 0. So we're ultimately left with is 2x plus 2y, y prime. And that's again because, remember, y is a function of x, so we're just doing the chain rule. Bring the 2 down, leave the inner function or the y untouched, then multiply by the y prime. So we've got this as our kind of intermediate step. We've taken the derivative of both sides, and now we're trying to isolate the y prime because we're ultimately, I forgot to write this from in the notes, we're trying to solve what's the derivative of y with respect to x. Well, that is this y prime. So if we can just algebraically solve for y prime, we're good to go. So we're going to leave the 2y, y prime on the left, and we're going to move the 2x to the other side. Then we're going to factor out y prime and divide by everything that's not a y prime. So that'll be y prime equals negative 2x over 2y. Y prime is equal to negative x over y. So the derivative with respect to x, the derivative of y with respect to x is negative x over y. And I think your notes might be wrong if you have the guided notes, so do fix this. It should be that negative because we subtracted that 2x over it. Let's look at a second example here, and the question is, what is the derivative of y with respect to x? So like before, we're just going to take the derivative of both sides. What we have here, though, is a much more complicated expression on the left and on the right. So let's just work through piece by piece. I'm going to start with the right because that's a little more familiar. We'll have 4 because the derivative of 4x is 4 and the derivative of 3 is 0. On the left, we've got a sum and we've got a product rule. So this first piece, if I take the derivative of that, I have to do the product rule. So that's going to be 3x squared sine of y, because that's the derivative of the x cubed times sine of y. And then I'm going to have to add x cubed times the derivative of sine of y, which is going to be cosine of y. But then again, because of the chain rule, this y, I need to take the derivative and multiply by that. If you're not sure what I did there, ask in class and I'll talk through it with you individually. So that's all of this is the derivative of that piece. And then we've got the y to deal with. Well, the derivative of y is just y prime. So then we've got this whole setup here. So now we've taken the derivative of both sides, and now we need to isolate y prime. So we're going to leave everything with y prime on the left, move everything with x to everything without y prime to the other side. So that's y prime plus x cubed cosine y times y prime is equal to x minus 3x squared sine of y. Now I want to factor out y prime on the left side. 1 plus x cubed cosine of y is equal to x minus 3x squared sine of y. And now I can divide by everything that's not y prime to leave y prime on its own. So y prime is equal to x minus 3x squared sine of y over 1 plus x cubed cosine of y, just like so. And it's kind of messy, it's kind of ugly, but the nice thing about this, you'll notice, is this y prime that we get always comes from either the chain rule or from a y by itself, which means it's always just going to be a single power of y prime, which means your factoring step, you might get some ugly thing that's left over when you pull it out, but your y prime is always going to be a nice, easy y prime at the end. You don't have to deal with quadratic formulas or factoring something clever. It's always just a single power of y prime. You pull out and then just throw everything kind of in the denominator of the other side. Let's take a look at one last example here. And this is xy squared plus 3x equals y squared. And the question is, what's the derivative of y with respect to x? You can try this if you want. It doesn't have sines and cosines to trip you up. So if you want to try, pause it. Otherwise, I will jump in right here. Okay, let's take the derivative of both sides. I'm going to start with that first term here. And that's going to be 2 times xy, because again, there's an outer function of the thing in parentheses squared. Then I need to multiply by the derivative of what's inside the parentheses because of the chain rule. So the derivative of what's in the parentheses is going to be x times y prime. So the first thing times the derivative of the second thing, plus the second thing, y, times the derivative of the first thing, which is 1. So that's what we've got here. Then, let me make sure, pause for a second so I can think this through. Yeah, so that's what we've got there. Then we've got the derivative of 3x, which is just going to be 3. And so that's our second term. And then on the right side, we've got the derivative of 2y, which is the outer function, the squared. We don't touch the inner function of y, and then we multiply by the derivative of that, which is y prime. So now I've got y primes on both sides, so I have to move everything with y prime to one side, everything without y prime to the other. So let's do some distribution first. We're going to get 2xy x squared y prime plus 2x y squared plus 3 is equal to 2y y prime. 2x squared y prime minus 2y y prime is equal to negative 2xy squared minus 3. Factor out y prime and get 2x squared y minus 2y is equal to negative 2xy squared minus 3. And that means we'll ultimately get y prime is equal to negative 2xy squared minus 3 over 2x squared y minus 2y. And so that's our derivative, that's our dy by dx. And again, it's take the derivative of both sides, rearrange, use chain rule, all of that, so you can get a y prime factored out, and then divide by everything else so that y prime remains isolated. This is another skill that's just going to take some practice, like combining all the derivative rules before, like the chain rule. It's just going to take practice getting used to seeing how these combine.